Hi everyone and welcome to Autodesk PowerMill. So we have started the module number 4, which is all about the advanced finishing toolpaths and machining strategies. And we have covered the 3D offset finishing, costed Z finishing, corner finishing, flow line finishing, parametric offset finishing, parametric spiral finishing, pattern finishing, profile finishing, project curve finishing, project line finishing, and the last we did the radial finishing operation. So right now today we are going to start a new topic, which is the raster finishing toolpath. Actually, we did the raster finishing in our 3D toolpath and finishing strategies, and we know that in the raster finishing we perform the finishing operation at an angle. Okay. So it's a straight line toolpath and you have to perform the operation in a straight way. So that's it with the finishing operation. In this toolpath, we are going to perform the finishing using a straight line toolpath. Okay. So let's get to the raster finishing. So here I have the Autodesk PowerMill, and let's go and import a model. Go to File, Import, and go to Examples. And let's go back to our favorite one, which is the cowling.dgk file. Click Open. So here we have the model. It's actually a surface model. It's named as cowling.dgk file. So let's go and do the raster finishing toolpath on it. So just go to the toolpaths and click on the finishing, and you will find out the real raster finishing here. Okay. Click OK. You have to define the name for your easy access. Let's say that raster finishing. You have to define the block for this model. Click Calculate to define the block. As you know that we are going to perform finishing operation, that's why we use the tool as a ball nose. So I set as 5 mm ball nose. Let's say that 5 mm BN for ball nose. Just go to the raster finishing and you have to define the fixed direction. That fixed direction means that you have to define the angle. Let's say that the angle is 0, 0. This means that it's from 0 degree angle to cut down that material. Then the thing is that starting corner, this means the left corner. Let's say go to the top position and it will show the left corner. So we have the right corner at the bottom over here, right corner of the upside here, left corner top on this side, and left corner lower on this side. So we have selected the left lower on this side. You can set as right upper or right lower. So the right lower would be this point. Okay. Angle is 0 degrees, or you can set as right upper on this side. Okay. So the ordering should be the downward direction, one way grouped, two-way joined, two-way and group, up and down. So let's say we first select the one way, set the tolerance 0.01, thickness 0. Let's say that the step over distance is 1.0 millimeters. It will automatically calculate the scallop height. This is 0.1. Just go to the rapid moves or links. Just click on the links. We have the straight, and save. Define the spindle RPM, set as 15,000. Cutting feed rate of 1500 and all this stuff. Okay. Just click on calculator and see how it actually looks like. So you see that the cutting tool is performing this operation from upper right corner and it's all the way straight at an angle of 0 degrees. Okay. So this is how the raster finishing works. It performs the finishing operation. Let's get to the raster at an angle of 45 degrees. You will see that it will perform its operation at a 45 degree. See that? So this is how you can change the angles. Let's say 90 degree. So it's going to perform its operation like that. So let's move and set this 90-degree upper right corner. And this is the one way. You see that it's all the way performing its operation in a one-way direction, and there are a lot of links created. So this way, this causes the cutting tool to perform unusual steps to cut down the material and take upward direction and go to save point and perform, then go back to its again to go back to its position to cut down that material. So we need to perform in a sequence way. So that's why we can select as two-way. You will see that all these up links and blunt feeds and skim feeds will be removed and it will join together. Okay, just click on calculate. You'll see that. So now, right now, there is no other unusual type of movements here. It only just all over the cutting tool at the save points on this position. You can also limitize it by using the angle. Let's say that it's 0-degree angle and just calculate it. You will find out that it will limitize your machining positions. Okay, so this is how it actually works. Or if you set this at one-way group, so it will actually looks like that. Okay, let's go and set this two-way, and here we have. So this is how it actually works like. So first of all, you have to set the step over distance 1 millimeter. Now, right now I set is 2.5. Let's see how it actually looks like. So this is how it is going to be cut down. Let's go back to set is 1.0 millimeters. Okay, calculate it, click OK, close, and that's it. Okay, go to simulation and perform the raster finishing toolpath. So this is taken from the upper right corner. It's a two-way cutting method. So this is how it actually works, the raster finishing. All the strategies right now we have did is very easy. There is no complicated things in it. There is no complicated parameters to set it. It's all about the major parameters we have to set it, like the angles, tool height, and save points. All these are things which we need to perform it. And that's it for the toolpath. If you have to perform the finishing strategy on a certain area, then you need to apply the boundary and set it trim inside or outside. Okay. So this is the raster finishing toolpath. Hope you enjoyed. Hope you like the toolpath strategies, finishing toolpath strategies, and it's simple. It's easy. Hope you understand the parameters. That's it for the raster finishing. Thank you very much.